Good morning, students. In the previous class, we discussed about problems on manufacturing problem. Today in this class, this is a diet problem. Okay. So for example, diet problem. This is the problem. Reshma wishes to mix. Reshma wishes to mix two types of food. Reshma wishes to mix two types of food P and food Q. Okay, food P and food Q in such a way that the vitamin content of a mixture, contains at least 8 units of vitamin A, and 11 units of vitamin B. So in that mixture contains P and Q. That mixture contains 8 units of vitamin A and 11 units of vitamin B. For food P cost 60 per kg, rupees 60 per kg, and food Q cost rupees 80 per kg. Now, food P contains 3 units per kg of vitamin A, 3 units per kg of vitamin A, and 5 units per kg of vitamin B. While food Q contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. Now we have to find out, determine the minimum cost of the mixture. We have to find the minimum cost of the mixture. Here two types of foods is there, that is P and Q. Okay, the mixture of P and Q at least 8 units of vitamin A, 8 units of vitamin A and 11 units of vitamin B. 11 units of vitamin B. At least 8 units of vitamin A and 11 units of vitamin B. And here the food P cost rupees 60 per kg. Here food P cost rupees 60 per kg and food Q cost rupees 80 per kg. Now in this food P contains 3 units per kg of vitamin A. The mixture containing 8 units of vitamin A, but in food P contains 3 units of vitamin A and 5 units of vitamin B. Okay. So food P cost is rupees 60 per kg and it contains 3 units per kg of vitamin A and 5 units per kg of vitamin B here. While the food Q contains 4 units per kg of vitamin A. Here food Q cost is 80 per kg and it contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. Reshma wishes to mix the two types of food P and food Q, and the mixture containing at least 8 units of vitamin A and 11 units of vitamin B. Okay, and the cost of the food P is 60 per kg and cost of the food Q is 80 per kg, and the food P containing 3 units per kg of vitamin A and 5 units per kg of vitamin B, while the food Q contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. So we have to determine the minimum cost of the mixture. This is the problem. So first we write the given data in the form of mathematical formulation. Okay, first we write mathematical formulation of the given data. So given data, that is solution. Let the mixture contain, let the mixture contain x kg. Let the mixture contain x kg of food P and y kg of food Q. Therefore, so x is greater than or equals to 0, y is greater than or equals to 0. This is non-negative constraint. First we write the given data. Here food P given, food P and food Q. Okay, so vitamins in kg, vitamins A unit per kg and vitamin B unit per kg. Okay, food P cost rupees per kg. Okay, and requirement unit per kg. Now the vitamin A in that food P containing vitamin A is 3 unit per kg and vitamin B is 5 unit per kg and cost of the food P is 60. For food Q, 4 unit per kg of vitamin A and 2 unit per kg of vitamin B and cost for this 80 and requirement here the mixture containing at least 8 unit per kg of vitamin A and 11 unit per kg of vitamin B. This is the table given. Okay, we have to write the mathematical formulation for the given table. At least the mixture containing at least 8 unit per kg of vitamin A and 11 unit per kg of vitamin B. Therefore we write mathematical formulation for this. That is 3x plus 4y which is at least, we write at least greater than or equals to symbol, at least 8 unit. Okay, for this 5x plus 2y which is greater than or equals to 11, and the total cost and food P and Q we denoted by Z, that is equals to 60x plus 80y. 60x plus 80y, this is the equation number 1, and subjected to the constraint we have to determine the minimum cost of the mixture. Okay, Z is equals to 60x plus 80y subjected to the constraint 3x plus 4y which is greater than or equals to 8 and 5x plus 2y which is greater than or equals to 11. We have to find out minimum cost of the food. Okay, now after mathematical formulation, so plotting a graph for the given equation. Okay, now for first equation, this is second and third. For second equation, when x is equals to 0, when x is equals to 0, this is of the equation 3x plus 4y which is equals to 8. Okay, x and y. When x is equals to 0, y, what is the y value? When x is equals to 0, what is the y value? Y value is equals to 8 divided by 4. 8 divided by 4 means 8 by 4, that is 2. That is 2. And y is equals to 0, x value is 8 by 3. 8 by 3. Okay, this is 8 by 3 approximation, approximately. So approximately that is 8 by 3 to 6, 2.6. That is approximately, this is 2.6. Okay. For second equation, 5x plus 2y is equals to 11. When x is equals to 0, when x is equals to 0, so what is y value? Y value is 11 by 2. Y value is 11 by 2 and y is equals to 0. X value is 11 by 5. 11 by 5. Now, here 11 by 2 means, here 11 by 2 means how much? 11 by 2. 5, 2 5s are 10 plus 1, 2 5s are 10. This is 5.5. And here 11 by 5 means 2 the remaining 10 to the 2.2 something. Okay, and x is greater than or equals to 0, y is greater than or equals to 0. For this, plot a graph. Okay. When x is equals to 0, this is origin 0, 1, 2, 3, 4, 5, 6, 7, that is. Now, when x is equals to 0, what is the y value is 2. This is 0 comma 2. This is 0 comma 2 and y is equals to 0. X value is 8 by 3. 8 by 3 means 2.6. 8 by 3 means approximate 2.6. Approximate 2.6 means it comes to this side. Okay. When x is equal, when y is equals to 0, what is x value? Approximate 2.6 here. That is 8 by 3 comma 0. Joining these two lines. Now this is the equation of the form. Now this is the equation. That is 3x plus 4y is equals to 8. This is the equation 3x plus 4y is equals to 8. For the second equation, x is equals to 0, y value is 11 by 2. So 11 by 2 means that is 5.5, approximately 5.5. That is 0 comma 11 by 2. 11 by 2 and y is equals to 0, x is equals to 11 by 5. 11 by 5 means 2.2, approximate 2.2, that is 11 by 5 comma 0. Joining these two lines. Now we have to find the feasible. This is the equation of the form 5x plus 2y is equals to 11. Now we have to find the feasible solution. And feasible solution. So here for first equation, first equation, so 0 plus 0 which is greater than or equals to 8, so it is false statement. Therefore for first equation C is above the origin. For the first equation is above the origin, this is above the origin. And for second equation, this is also 5x plus 2y which is greater than or equals to 11, that is 0 plus 0 which is greater than or equals to 11 means it is also a false statement. Therefore the shaded part is above the region, above the origin. See here no common region. Here no common region is determined, all the constraint including non-negative constraint. Okay, therefore this region is called unbounded region. Unbounded region, just we have to calculate, this is unbounded region, this is only come to above the region, the shaded part like this. Okay, now we have to find the corner point for this. This is one point, this is one point, and this is one point, and this is one point. Intersection of this point. These are the corner points for this. These are the corner points for this, and we have to write the corner point. This is unbounded region. This is unbounded region. Write the corner points. That is corner points A of what is 8 by 3 comma 0, and we don't know B value, and C 11 by 5 comma 0. Okay, to solve these two intersection of lines, so write the equation to solve these two intersection of a line. Write the equation, that is 3x plus 4y is equals to 8, and the second equation, third equation, 5x plus 2y is equals to 11. Okay, see, for second equation multiply by 2. For second equation we multiply by 2, we get 4y get cancelled on subtracting. Okay, so multiply by 2, third equation, what do we get? That is, I will write 5x plus 2y which is equals to 11. So multiplication, that is 10x plus 4y is equals to 22. 11 2s are 22. And for the equation 2, 3x plus 4y is equals to 8. On subtracting, 4y and 4y get cancelled. Okay. Next, 10x minus 3x. 10x minus 3x, that is 7x. Okay, that is 7x. 7x is equals to, so 22 minus 8, that is 14. Therefore x is equals to 14 divided by 7, 2. X is equals to 2. X is equals to 2. And y is equals to, so that is we substitute x value in the equation number 2, we get the y value, that is 3 into 2 plus 4 into y is equals to 8. So 6 plus 4y is equals to 8. 4y is equals to 8 minus 6, that is 2. Okay, 2, y is equals to 2 divided by 4, that is 1 divided by 2. Here x value is 2 and y value is 1 by 2. This is the point. Point B is x is equals to 2 and y is equals to 1 by 2. X is equals to 2 and y is equals to 1 by 2. Okay. Now the corner points. A 8 by 3 comma 0, and B 2 comma 1 by 2, and C 11 by 5 comma 0. Okay, we substitute in the objective function, that is z is equals to 60x plus 80y. 60x plus 80y, we get the minimum cost. Now this is corner points. And corresponding values of z, 60x plus 80y, and corner points are A 8 by 3 comma 0, and B 2 1 by 2, and C 11 by 5 comma 0. Now we substituted in the objective function, we get for z is equals to 60x plus 80y. For point A, that is equals to 60 into, what is x here? X is equals to 8 by 3 plus 80 into 0. Y value is 0. Therefore, 3 2s are 8 2s are 160. 8 2s are 60. 0, 20 into 8 is 160. Here point A gets 160. And so point B is, similarly we substitute 60 into 2 plus 80 into 1 by 2. For second point, 60 into 2 plus 80 into 1 by 2. This is 120. Okay, 120 plus 40, that is equals to 160. Your point B gets 160. And finally point C, that is z is equals to 60x plus 80y, 60 into 11 by 5 plus 0, 80 into 0. Okay, that is equals to, this is 14, 60 into x, that is 11 by 5. 5 ones are 5. What we get? On the 5, we are 10, 12. So that 10. That is equals to 12. Okay. Just once again. Sorry for this. This is not 11 by 5. This is 0, 11 by 5. 0, 11 by 5. 0, 11 by 5. Okay. Now, sorry. By 5, like this. Okay. Okay. So we take this point. This is the 0, 11 by 5. We take this point 0, 11 by 5. Okay. This is not a point. This is not a point. We get 440. We get 440. We take this point. We take this point. Okay. The corner point, that is, this is the one point, this is second point, and this is third point. This is third point. Therefore, point C 0, 11 by 5, we get 440. We get 440. Now the minimum cost. Now the minimum cost is 160. 160 at the point. A is equals to 8 by 3, 0, and B is equals to 2, 1 by 2 is 160. Just see, observe. We miss here. When x is equals to 0, so here x is equals to 0. X is equals to 0. Y value is 11 by 2 and y is equals to 0. X value is 11 by 5. Okay, take it 0, 11 by 5. We get the answer. So 440. Finally, so wait, 11 by 2. This is the 11 by 5. Okay. So finally, the minimum cost of food. Finally, the minimum at the food is A is equals to 8 by 3, 0, and B is equals to 2, 1 by 2. That is 160. First, we write mathematical formulation of a given data, and we plot a graph. Okay, we plot a graph. We get the answer. So that is a corner point and corresponding value of Z. Now the next question. Just we miss this point. Here 0, 11 by 2. This is 1 by 2, 11 by 2, 11 by 5, 0. We miss here. Okay. This is 11 by 2. 11 by 2, not 11 by 5. Check it once again. Here we miss the points. 0, 11 by 2 here, and 11 by 5, 0 here. Okay. The corner points. The points are 8 by 3, 0, 2, 1 by 2, and 0, 11 by 2. For 8 by 3, 0, we get 160, and for this 2, 1 by 2, we get 160 on substituting the Z value, and C value 0, 11 by 2, so we get 440. Therefore the minimum value, minimum cost of the mixture is 160 at the point 8 by 3, 0, and 2, 1 by 2. Now next question. This is a manufacturing problem. See, manufacturing problem. A manufacturer produces nuts and bolt. Nuts, we know nuts and bolt. Nuts and bolt. It will take 1 hour of work on machine A. Here two machines is there, machine A and machine B. Machine A and machine B. So it is take 1 hour of work on machine A. Machine A and 3 hours work. 3 hours work on machine B. Machine B to produce the package of net. To produce the package of net. To produce the package of net, a machine A takes 1 hour work on machine A. 1 hour work on machine B takes 3 hours. Machine B takes 3 hours. Okay. And it takes 3 hours on machine A for bolt. It takes 3 hours on machine A and 1 hour on machine B. 1 hour on machine B to produce a bolt. He earn a profit of rupees 17.50 per package on nut. And rupees 7 per package on bolt. Rupees 7 per package on bolt. Now the question, how many package of each should be produced? How many package of each should be produced each day so as maximize his profit. Is operate the machine for at most 12 hours a day. At most 12 hours a day. Here the question, the manufacturing produces nuts and bolt. The manufacturers produces nuts and bolt and two machines is there, machine A and machine B. Okay, for machine A it takes 1 hour work. For machine B take 3 hours work for producing a nut. And for bolt the machine A takes 3 hours and machine B takes 1 hour for producing a bolt. And here a profit on package of a nut. Package of a nut is 17.50. Okay, profit. And for bolt, his profit is 7 rupees. To package of a bolt. Okay. Now, how many package of each should be produced? Here the question: how many package of each should be produced each day to maximize his profit? And he operates the machine for at most 12 hours. How many package of nuts and bolts are produced? That is the question. Okay. We write the data first. Let the manufacturer produce X package of nuts and Y package of bolts. Solution. Let the manufacturer produce X package of nuts and Y package of bolts. Therefore, X is greater than or equal to 0, Y is greater than or equal to 0. Okay, so I will write the given data. For machine A and machine B, two machines is there, and it produces nut and bolts, and availability, he operate at most 12 hours availability. For to produce the nut, the machine weight takes 1 hour and machine weight takes 3 hours. Okay. For bolt, machine weight takes 3 hours and machine weight takes 1 hour. The availability of a time at most 12. Here also at most 12. And the profit of the nut on the package of a nut, that is the profit on the package of nuts is rupees 17.50 and package of board is rupees 7. Therefore the constraint, we write the constraint, that is z is equals to 17.50 into x plus 7y subjected to the constraint. First we write the nuts constraint, that is x plus 3y. Okay. X plus 3y which is less than or equals to 12, that is at most x plus 3y is less than or equals to 12, and the second one is 3x plus y which is less than or equals to 12. 3x plus y which is less than or equals to 12. This is utmost condition. For at least we take greater than or equals to. This is utmost condition. Now we have to find out how many package of nuts and board, okay, he produced. Okay. Now for this we take a graph on this graph. For first equation, x plus 3y which is equals to 12. When x is equals to 0, what is y value? Y value is 12. Y value is 4. When x is equals to 0, y value is 4, and y is equals to 0, x value is 12 for first equation. For second equation, 3x plus y which is equals to 12. When x is equals to 0, x is equals to 0, y is equals to 12, y is equals to 0, x is equals to 4. So this is the points. Now graph for these points. Now when x is equals to 0, y is equals to 4. This is approximate 0, 4. Next, when y is equals to 0, x value is 12. This is approximate 12, 0. Joining these two lines, now this is of the equation x plus 3y is equals to 12. And for second equation, x is equals to 0, y value is 12. 0, 12. And y is equals to 0, x value is 4. This is 4, 0. Joining these two lines, approximate these two lines. Okay. Now this is the equation 3x plus y is equals to 12. Now we have to find the feasible region. For this condition, the shaded part is come towards. For first equation, the shaded part is come towards origin side. And for second equation also, it come towards origin side because of less than symbol is given. Okay, the shaded region and the visible regions are these points. This is shaded region and this is the visible region. This is the visible region. Now we have four corner points. We have four corner points, that is corner points, origin 0, 0 and point A is 4, 0 and point B we don't know and point C 0, 4 and corresponding value of Z, that is Z is equals to 17.50 into X plus 7Y. Okay, we find out the intersection of these two lines for solving these two equations. We get the points, that is already know how to solve the equation. We get the points is 3, 3. We get the points 3, 3. Okay. For point B is 3, 3. Substituted in the objective function. So we get for point A 70 and 73.5 and 28. Now on substituting directly we get the answer, that is origin 0, 0 is 0 and we substitute 17.50 into 4. 17.50 into 4 we get 70 and 3, 3 70.50 into 3 plus 7 into 3 we get 73.5. Finally 6, 4 0, 4 7 into 4 that is 28. Therefore the maximum is 73.5 at the point 3, 3. Therefore 3 package of final conclusion, 3 package of nuts and 3 package of bolts should be produced each day to get a maximum profit. Therefore, conclusion, 3 package of nuts and 3 package of bolts you should produce each day to get maximum profit and the profit is rupees 73.50 is the final conclusion on simplification. Okay, so in the remaining problem you do it in home. Okay, if you have any doubt just call back or ask to WhatsApp number. I already sent the notes, complete notes. Okay, you have to write it in home. If you have any doubts in this problem, just message me or call back. No doubt. Done.